Hello everyone and welcome back to CodeChef. When we design a database, we are not just storing data. We are designing how information lives, grows and stays correct over a period of time. A poorly designed database may work initially, but as data increases, it starts causing problems like redundancy, inconsistency, and unexpected errors. This is where normalization becomes essential. In this video, we will explore why normalization is needed, how different normal forms from 1NF to 5NF work, and how they help us remove anomalies and design clean, efficient, and reliable databases. So let's dive in. What is normalization? Normalization is the process of structuring a relational database in accordance with a series of normal forms so as to reduce redundancy and dependency while preserving data integrity. When we have multiple tables in a database, we need to set relationships between those tables, and that is how a database system is formed. But as the number of tables increases, redundancy and dependency creates problems in maintaining the data integrity. For that, we use different normal forms. And the process of using those normal forms to reduce redundancy and dependency while preserving the data integrity is known as normalization. Objectives of normalization. Normalization aims to eliminate redundant data, ensure logical data dependencies, prevent data anomalies. We will discuss what data anomalies are, then improve maintainability and preserve data integrity. Now, types of anomalies. So first is insertion anomaly. It occurs when certain attributes cannot be inserted without others. For example, we cannot add a new department unless at least one employee exists. So when the insertion of one attribute depends on another, it creates insertion anomaly. As we can see in the example, we want to create a new department, but we cannot do that unless one employee exists in that department. Second is update anomaly. It occurs when a single fact is stored in multiple places. Example, updating department name in 100 employee records. So let's suppose I want to update the name of department in one table, but the department name is being used in 100 other employee records. So it is very important that if I am updating the department name in one table, then department name is updated in the other records as well, which are using this column. And in case we fail to do that, it creates update anomaly. Next, deletion anomaly. It occurs when deleting data removes unintended information. For example, deleting last employee removes department data. Let's suppose I am deleting one complete row from a table, but some columns from that row has data that I will need in future or that I do not want to delete will also get deleted because I am deleting the entire row. So this kind of action will create deletion anomaly. First normal form, which is also known as 1NF. A relation is in first normal form or 1NF if first, all attributes contain atomic values. Atomic values means values that cannot be broken down into multiple values. Then second, no attribute contains sets, list, or repeating groups. Then third, each tuple can be uniquely identified. That means each row or entry can be uniquely identified. Now why 1NF exists? Relational model is based on set theory, where each cell must contain exactly one value, that is atomic value, and composite or multi-valued attributes violate relational theory. So let us practically see what problem is being solved by 1NF. So here we have a table which has multi-valued attribute problem. For column student, we have entry Aisha. For column course, we have SQL, C++. So there are two different values which are written in the same cell. Now, can these two values be separated in two different rows? Yes. So this entry is not atomic. Therefore, this table is not following the rule of 1NF here. Now, why do we call it a problem? Because searching any element from such kind of a record becomes very complex, where multiple records are stored in a single cell. Then updates are error prone and we cannot enforce constraints on such rows. Now let us discuss the conversion principle to convert this kind of table in 1NF format. Break repeating values into multiple rows and not columns. 1NF does not remove redundancy, it only ensures structural correctness. So here in column student, I have repeated the entry. So redundancy is there. Redundancy means repetition of records. Aisha, I have written this 2 times, but in column of course, now we have a single value in each cell. So Aisha SQL and Aisha C++. This is how 1NF works. Second normal form or 2NF. A basic rule of 2NF is that relation must already be in 1NF. That means it must have atomic values. A relation is in second normal form if it is in 1NF plus every non-prime attribute is fully functionally dependent on the entire primary key. Now before we learn more about 2NF, let's see what are prime and non-prime attributes. Prime attributes are part of any candidate key, while non-prime attributes are not a part of any candidate key. What are candidate keys? Keys that have the potential to become primary key for a given table. A candidate key is a column or set of columns that can uniquely identify each row in a table. Partial dependency. This is the root problem. So partial dependency occurs when a non-prime attribute depends on only part of a composite key. This violates the minimal dependency principle. Now what is a composite key? Composite keys represent combined entity. So when we are creating a primary key by combining 2 or more columns, then such kind of primary keys are known as composite keys. Any attribute that is not depending on full identity is misplaced. So 2NF applies only when the primary key is composite. That means it applies only when the primary key is made up of a combination of multiple columns and not a single column. Now what 2NF actually fixes? First, redundant attribute repetition. Second, update anomaly caused by partial dependency. And third, logical separation of entities. Then third normal form or 3NF. A basic rule of 3NF is that relation must be in 2NF. So just like for maintaining 2NF, a relation must be in 1NF. Similarly, for 3NF, the relationship must be in 2NF. And a relation is in third normal form if first, it is in 2NF. Second, no non-prime attribute is transitively dependent on the primary key. We will learn about this, what is a transitive dependency. But after applying 3NF, each table represents one entity and one entity only. This makes the database design clear, stable and easy to maintain. What is transitive dependency? A transitive dependency occurs when a non-key attribute depends on another non-key attribute instead of directly depending on the primary key. In such cases, the table stores indirect information, which leads to redundancy. And third normal form removes transitive dependency by ensuring that non-key attributes depend only on the primary key and nothing else. So this is something very basic. Why do we make primary key? So that we can uniquely identify the records. So the attributes that are non-key should depend purely on primary key to avoid any kind of redundancy or errors in the data. And this we make sure using the third normal form. Why is transitive dependency dangerous? First, because it causes hidden redundancy. Second, it breaks single fact storage principle. So when attributes depend on other attributes that are non-key or that are not reliable, Then data is stored on the basis of multiple different facts, which breaks the single fact storage principle. And it makes schema unstable. Schema means the database design. Now each table should represent one entity type, not entity plus property of another entity. What are the results of 3NF? Clear entity boundaries, minimal redundancy, and stable schema or database design. Voice code normal form, BCNF. So this form is stricter version of 3 normal form. Sometimes even a 3NF table can have anomalies if there are multiple candidate keys. Candidate keys means keys that have the potential to become a primary key, and certain dependencies violate strict rules. So in BCNF, every determinant must be a super key. Super key means all the values must be able to uniquely identify the rows. So this means that if an attribute determines another attribute, it must uniquely identify the entire row. BCNF eliminates advanced anomalies that are not handled by 3NF, but it may require additional table decomposition and sometimes sacrifice dependency preservation. Next is fourth normal form or 4NF. Fourth normal form deals with multi-value dependency. A multi-value dependency occurs when 2 or more independent attributes depend on the same primary key. For example, a student may have multiple skills and multiple hobbies, but skills and hobbies are independent of each other. Storing all of them in a single table creates unnecessary combinations and redundancy. Fourth normal form removes this issue by splitting independent multi-valued attributes into separate tables. This ensures that each table represents only one independent relationship. So when multiple attributes which are independent depend on the same primary key, it makes unnecessary relationships in the table, which creates data redundancy. So fourth normal form removes this kind of issue by dividing these independent relationships into separate tables, and then each table represents only one independent relationship. Fifth normal form or 5NF. Fifth normal form, also known as project join normal form, deals with join dependency. A table is in fifth normal form when it cannot be decomposed further without losing information. That means it is already in fourth normal form, because in fourth normal form we are actually splitting the data in such a way that each table has a single independent relationship. So a table is in fifth normal form when it cannot be further decomposed without losing information. This normal form is mostly theoretical and is used in very complex data design. In practical systems, most databases work efficiently in the third normal form or BCNF. Referential integrity. Normalization defines the structure of tables, but referential integrity ensures correctness of relationships. Referential integrity means that a foreign key must always reference an existing primary key. This prevents orphan records and maintains consistency between related tables. Referential integrity is enforced using foreign key constraints along with actions like cascade, set, null, restrict. We have talked about some of these actions in multiple tables part 3. These rules ensure that changes in one table are correctly reflected in the related tables. Normalization is not about memorizing rules or forms. It is about understanding how data should be structured to reflect reality accurately. By applying normalization correctly, we reduce redundancy, prevent anomalies, and ensure that our databases remain consistent, scalable, and easy to maintain. If you truly understand concepts like functional dependency, normal forms, and referential integrity, you are not just learning DBMS, you are learning how real-world systems are built. You can find more information about normalization on the CodeChef platform, so make sure you check it out.